Maybe we should get going. X is 3.
Can you what? Where are they at?
All right, let's check in. I want to make sure we're off to a good start. I hear a lot of discussion when you're working. That's good. Go back to me now. Let's go ahead and do this first one, the first expression, and substitute in 1 and 3. So 8 times 1 is, say it out loud, 8 minus 4 is 4. Now let's do it with 3. We'll use a different color marker. 8 times 3 is
24.
minus 4, 20. So for each expression, you should have those two different values, and we'll compare them. If you're still working, raise your hand. We can give you some more time. Okay. I'll check back in here in a second. If you're done, if you are finished, then you can go ahead and move on and look at the try it question. So maybe you can be a helper and help explain that when we get to it. Depends on you try to get one already or using it both times. You use 3 the second time. All right, we're right at the end of, some of you are right at the end. Let's go ahead and check in, and we'll finish this up. So eyes up here. So for the first expression, when we used 1, we had 4. We would use 3. We had 20. Let's go ahead and do this for the second expression. What is 4 times 1? You say it. 4. What is 4 times 3?
12.
So what have we seen so far? Yeah, go ahead. Yeah.
Oh, that the 1 equaling both of them, the 3 and then.
Yes. So my advice there is use a different value other than 1 when you're testing these to see if they're equivalent in the future. So make a note of that. What do I want you to learn from this? What I just say?
Try something, a different number other than 1.
When you're trying to check to see if these expressions are equivalent today, use a different value than 1 for your variables. All right, let's go ahead and finish it out. 4 times 2 is 8. So we have 8x. 4 times 1 is
8.
4 times 1 is
4.
4. And 8 times 1 is 8 minus 4 equals 4. So yeah, if we would have just used 1, you probably would have said, yes, Mr. DeHart, these all 3 are equivalent. But you would be wrong, because when we use a different value, we get
So it depends on
3.
the variable.
It does. 3 times 8 is 23 minus 4, 20. So 2 of them are equivalent. The middle one is not. So you should have put 4x in the non-equivalent and the other 2 expressions as being equivalent. Evan, I want you to say what you just said out loud one more time.
So it depends on the variable.
It depends on the variable. Absolutely. But you need to use the variable, the value for that variable, for both expressions that you're comparing. So let's look at another example. So what Evan said, it depends on the variable. Let's not use 1 for this. So which of these following expressions are equivalent? And explain. So I would choose, well, you tell me, what's the first step that you're going to do, and what value are you going to choose for your variable? Yeah, Gia.
I'm gonna rewrite the problem and evaluate the y. I choose 2.
She is going to make y equaling 2. That's an easy one. So everyone do that. Choose a variable, a value for the variable. She's going to use 2. Use 2 here. Use it for this expression, and also use it for this expression. Then answer the question, which of the following expressions are equivalent?
I did 2.
And we're still in the try it, practice it type phase. So if you want to work with your shoulder partner, you are free to do that. And I should see your work on your whiteboard as I'm walking around. If you need help, you have a partner, and you also have me.
Have you done it? Marker number 3?
No, one, book 2 of 30, 25 lines.
So then try with 3.
Choose 3 to work.
One and one.
This one is 10 times 5 is 5. And this much goes
A few more people are still working, so let's give them a little more time.
This problem for the number 3, 5, 2, y plus 1. Can you do the product pieces, or you just go right?
You would take 5 times 2. 10y. 5 times 1 is 5, so 10y plus 5. And you would do 2. So 10 times 2 is 20.
Yeah, are you asking about order of operations?
It does. Right there, in the house. Hey, Gia, there's food dots up
I choose 5.
Yeah.